really means. But what do you do if an object has an irregular shape? Well, let's say like this. Well, then you can determine its volume by a technique called water displacement, which I'm going to assume you already know about to save some time here. If not, you can do a Google search using the phrase water displacement. It basically involves simply dropping the object into something like a graduated cylinder that already has some water in it, and observing by how much the volume of the water increases. Now, some students will say to me, come on, do I really need to do all this? I mean, really go to school, hold up objects, estimate their masses and their volumes, and then measure them? I don't want to give an absolute, uncompromising yes to that question, because I know that there are many students who have the ability to develop a good intuitive understanding of concepts like mass and volume without having to do all of this. But if you belong to the majority of students who may not immediately have this intuitive understanding, then I strongly suggest that yes, you do this. As I said, the learning that occurs is very subtle. Students are not always even aware that it is occurring. But remember the weight and volume exercises. Would you have had much of an idea of how many grams a particular object weighed before holding a nickel, realizing that this was about 5 grams, and then estimating other objects? Or would you have been able to estimate some of those volumes in cubic centimeters before going through some of the exercises you did in SAW? Only you can answer that question. Put in the effort that you personally need. It's probably going to be time very well spent. Mass in grams and volume in cubic centimeters are concepts in units that are going to come up again and again and again from now until the end of these lectures and in your chemistry course from the first day virtually to the last. And now comes the final idea, the concept of density. Density is defined as mass per volume, commonly specified as a number of grams per cubic centimeter. For example, I might say that a substance has a density of 3.45 grams per cubic centimeter, which is usually represented in one of the variations that you see on the screen. Now, what does that really mean? Well, in the last lecture, we talked about a this per that. Anytime you have a this per that, in this case it's grams per cubic centimeter, that's telling you how many of the numerator you have for one of the denominator. So when an object has a density of 3.45 grams per cubic centimeter, what this is saying is that if you have a little cube 1 centimeter on a side, the mass of that cube will be 3.45 grams. That cube will contain 3.45 grams of whatever this stuff is. But here's a key idea. Just because the density is 3.45 grams per cubic centimeter does not imply in any way, shape, or form that we have only 1 cubic centimeter of the material, or that the amount of this material we would have would weigh 3.45 grams if we put it on a scale. It's a ratio. If we had 2 cubic centimeters of this stuff, it would weigh twice as much, or 6.90 grams. But its density wouldn't change, because 6.90 grams for 2 cubic centimeters is the same as 3.45 grams for 1 cubic centimeter. Now let's suppose for a moment that you are not sure that you really understand the concept of density. What could you do to solidify the concept of density, which involves a relationship between the mass and the volume of something, as opposed to just the separate concepts of mass and volume? You go back to those objects. What I would suggest you do is take several objects, whatever you can find. Metallic objects are good since they don't dissolve in water. Hold the objects in your hand and try to arrange them from the lightest to the heaviest, from the least number of grams to the greatest number of grams. Don't worry about what their actual masses are. When you've arranged them, then actually measure their masses and write the masses down on a piece of paper. Then try to arrange the objects by volume, from the smallest object to the largest object. After you've done that, then measure the volumes and write them down. After you've done all of this, hide those numbers. And here's the biggie. Now try to rank the objects by their densities, from the least dense, the one that had the fewest grams per cubic centimeter, to the most dense, the one that had the most grams per cubic centimeter, without consulting your previous numbers. Finally, divide the mass of each object by the volume of each object to calculate their actual densities and see how well you did. If you did reasonably well, don't expect to do this perfectly or even close to perfectly. It isn't easy to do. But if you did it even reasonably well, you truly understand the concept of density. If you didn't do well, then do it again. Now, it would be nice if you could stop the video here, go to the lab and do all of this. If this is actually possible, then do it. Stop the video and come back to it after these concepts have been solidified in your mind. Assuming you have done that, or whatever you're capable of doing, you are now prepared to work density problems. Our first problem is, a substance has a density of 4.55 grams per cubic centimeter. What is the mass of 6.00 cubic centimeters of this substance? Now, you may have decided, despite all that we've said, to solve this problem by using the equation D equals m over v. Or perhaps you even solved it by proportions or factor label. But let's just solve this problem by thinking logically. The problem says that the density of this substance is 4.55 grams per cubic centimeter. We know that what this is really telling us is that 1 cubic centimeter of this material would have a mass of 4.55 grams. If I had one of those little cubes of this stuff, the cube would have a mass of 4.55 grams. Now, if one little cube has a mass of 4.55 grams, then what do you think 6 of these little cubes would weigh? I would suggest 6 times as much. So just take the mass of 1 cubic centimeter, 4.55 grams, and multiply it by 6, since I had 6 cubic centimeters, not 1. That, to me, is the most simple, logical way to solve the problem. And solving it this way would seem to indicate that you really do understand what density is all about. Let's try problem number 2. A sample of a substance has a mass of 12.68 grams and a volume of 8.33 cubic centimeters. What is its density? Density tells you how much 1 cubic centimeter weighs. If you want to know what 1 cubic centimeter weighs, if you want to know how many grams there are for 1 cubic centimeter, then all you have to do is divide the number of grams by the number of cubic centimeters. Remember, anytime you divide two numbers, you are making the denominator 1. So 12.68 grams divided by 8.33 cubic centimeters means that the density, the mass of 1 cubic centimeter, would be 1.52 grams per cubic centimeter. And another. A substance has a density of 5.38 grams per cubic centimeter. The total mass of the sample is 2.33 grams. What is the volume of the sample in cubic centimeters? This density problem is the key problem. If you understood this problem and worked it correctly, it is very safe to say that you really understand density. Here's what should have been going through your mind. The problem tells you that you have an object with a mass of 2.33 grams. That's an amount. But it weighs 5.38 grams for 1 cubic centimeter. This little cubic centimeter weighs 5.38 grams. But I only have 2.33 grams. Do I have more or less than 1 cubic centimeter? I must have less than 1 cubic centimeter. In fact, I must have this fraction, 2.33 over 5.38 of a centimeter. This is the amount divided by the this per that, just like students divided by students per room. Students divided by students per room was rooms, and grams divided by grams per cubic centimeter would be cubic centimeters. 2.33 grams divided by 5.38 grams per cubic centimeter means that I have about 0.433 cubic centimeters of this material. And now for the real test. I'm going to ask you 5 questions, one at a time. The possible answers to each question are lead, styrofoam, neither, or can't tell. I'm assuming you know that lead is denser than styrofoam, but do not know their actual densities, which you are not supposed to try to look up to answer these questions. Question number 1. Which has a greater mass, 6 grams of lead or 7 grams of styrofoam? Styrofoam. Mass is measured in grams. Mass is mass. 7 grams of anything is a greater mass than 6 grams of anything else. The fact that one was lead and the other was styrofoam was irrelevant. Second question. Which occupies a greater volume? 5 cubic centimeters of lead or 5 cubic centimeters of styrofoam? Neither. In a similar manner, volume is volume. 5 cubic centimeters represents a certain volume of some material. What it is doesn't matter. The volumes are equal. Third question. Which occupies a greater volume? 5 grams of lead or 5 grams of styrofoam? Styrofoam. Styrofoam is not as dense as lead. This means that there are fewer grams in 1 cubic centimeter of styrofoam than there are in 1 cubic centimeter of lead. If there are fewer grams in a cubic centimeter, then you're going to have to take more cubic centimeters before you get the same mass of styrofoam as you have of lead. Next question. Which occupies a greater volume? 9 grams of lead or 50 grams of styrofoam? Styrofoam. Again, styrofoam is not as dense as lead. As we saw in the last question, it takes a larger volume of styrofoam than lead just to get equal masses. In this case, we actually have to have an even greater mass of styrofoam than lead. So it's going to take a much larger volume of styrofoam to get 50 grams of styrofoam than to just get 9 grams of lead. And the last question. Which occupies a greater volume? 50 grams of lead or 9 grams of styrofoam? You can't tell. Can't tell. No. You have a greater mass of lead than you do of styrofoam, which would tend to make the volume of the lead be larger than the styrofoam. Greater masses tend to occupy larger volumes. But styrofoam isn't as dense as lead, so a given mass would occupy a larger volume. The problem is that these two things are going in opposite directions. The greater mass of lead tends to make its volume be the larger, but the lower density of styrofoam tends to make its volume larger. Without the actual densities, I have no way of knowing which factor is more important, so I can't answer the question. I hope this lecture has shown you what I mean when I keep emphasizing the importance of trying to develop a real understanding of a concept rather than being satisfied with just learning a formula that will, quote, get us through the day, so to speak. Trying to develop understanding takes a lot of effort at first, but in the long run, it is the easier path to follow.